Today we are going to start trigonometry, one of the most important branches of mathematics. The word trigonometry is derived from two Greek words, trigonon and metron, which means the measurement of a triangle. But today, its scope has been extended to a great extent, and it also includes the study of a polygon and a circle. Hence, this subject is further divided into two branches. Number one, plane trigonometry. Number two, spherical trigonometry. So the two branches of trigonometry are: number one, plane trigonometry; number two, spherical trigonometry. Plane trigonometry deals with the angles and figures drawn on a plane, and spherical trigonometry deals with the angles and figures drawn on the surface of a sphere. So, either in plane trigonometry or in spherical trigonometry, we are going to deal with the angles and figures drawn on a plane or on a sphere. So hence, first let us know the definition of an angle. Suppose this is a fixed straight line fixed here at this end, so that this end can be moved. So this end may be moved like this, or it may be moved like this. So this is OA, and when moved in this direction, it came to the position OB, and when moved in this direction, let us say that this position is OB dash. In any way, the amount of rotation made by this straight line from one position to another position about a fixed point is called the angle. Hence, the amount of rotation made by a straight line from one position to another position about a fixed point is called the angle. The amount of rotation made by a straight line from one position to another position is called the angle. So this is the definition of an angle. Further, if this straight line is moved in the anti-clockwise direction, the angle is considered to be positive, and when this straight line is moved in the clockwise direction, this angle is to be considered as negative. So the angle made in the anti-clockwise direction is positive, and the angle made in the clockwise direction is negative. Now, measurements of an angle. Measurements of an angle are of three types. Number one is sexagesimal system, which may also be called as a British system. Number two, centesimal system, which is also called as a French system. The third one is a circular measure or a radian measure. So measurements of an angle are of three types. Number one, sexagesimal system. This may also be called as British system. Number two, centesimal system. This may also be called as French system. Number three, circular measure. Or radian measure. Now let us know about the first system, sexagesimal system. OX is a horizontal line, OY is a vertical line. The angle between the horizontal line and the vertical line is known as a right angle. In sexagesimal system, this right angle is further divided into 90 equal parts called degrees. Hence, in a sexagesimal system, one right angle is equal to 90 degrees. Symbolically, this is written as 90 degrees. And 1 degree is equal to 60 minutes. This is symbolically written like this. And 1 minute is equal to 60 seconds. And this is written as like this. So in sexagesimal system, one right angle is further divided into 90 equal parts called degrees. So one right angle is equal to 90 degrees. Symbolically, this is written like this. 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. Now let us know about the centesimal system. In the centesimal system, the right angle is divided into 100 equal parts and each part is called 1 grade. Hence, one right angle is equal to 100 grades. This is written as 100 to the power g. 1 grade is equal to 100 minutes. And 1 minute is equal to 100 seconds. So in centesimal system, one right angle is further subdivided into 100 equal parts called grades. So one right angle is equal to 100 grades. 1 grade is equal to 100 minutes. And 1 minute is equal to 100 seconds. The next one is the circular measure or radian measure. Let this be a circle with center O and a radius small r. Let A and B be any 2 points on the circumference of the circle, and in particular this curve AB is called the arc of the circle. Now, let the ends of the arc A and B be joined to the center of the circle. Now, let the length of the arc AB be L units and this radius is R. Now, the angle between the two lines AO and BO is same as the angle subtended by the arc AB at the center of the circle in radians. Hence, if this is marked as theta radians, theta power c means theta radians, then this theta radians is the ratio between the length of the arc L and the radius of the circle R. Therefore, theta radians is equal to L by R. So the angle subtended by the arc of a circle at its center is the ratio between the length of the arc and radius of the circle in radians. So theta radians is equal to L by R. And if the length of the arc and the radius of the circle both are equal, then this becomes 1 radian. When theta is equal to L by R, it is understood that theta is radian. L is equal to R theta. Further, we have to remember one more point about the area of sector OAB. Area of sector OAB is equal to half L R square units. This is also equal to half R square theta square units, since from this L is equal to R theta. So theta radians is equal to L by R and L is equal to R theta. Area of the sector OAB is half LR square units. It is also equal to half R square theta square units. Now, this is a circle. Let us take 2 points on the circumference of the circle as the ends of the diameter. Previously, we have taken A comma B on the circumference of the circle, but not as the ends of the diameter. But now we have taken both the points A and B to be the ends of the diameter. And in the beginning, we have seen that this is a horizontal line and this is a vertical line. This angle is right angle and it is 90. So therefore, this is also 90, this is also 90, and this is also 90. The complete angle is 360 degrees. Therefore, from here to here, this angle is 180 degrees according to the sexagesimal system. So when A and B are the ends of the diameter of a circle of center O, then this angle AOB or the angle subtended by the arc AB at the center of the circle in sexagesimal system is equal to 180 degrees. The same angle in radian measurement is length of the arc AB by radius of the circle. Length of arc AB by radius this is equal to the circumference of the circle is 2 pi r. Therefore, this is pi r. By radius is r. R and r gets cancelled. This is pi. So the same angle in sexagesimal system 180 degrees is equal to pi radians. Hence pi radians is equal to 180 degrees. Once again, look here carefully. A and B are the ends of the diameter of a circle of center O, and this is a vertical line and this is a horizontal line. The angle between the vertical and the horizontal is 90 degrees. So completely this angle is 360. So from here to here it is 180 degrees. Now 180 degrees is the angle made by the arc AB at the center of the circle. Now, in radian measurement, the ratio between the length of the arc AB and the radius of the circle R is the angle subtended by the arc AB at the center. Therefore, the same angle is length of the arc AB by radius. Circumference is 2 pi r. Therefore, this length is pi r by r. Therefore, this is pi radians. So, therefore, pi radians is equal to 180 degrees. So usually when we ask for pi, some students they say that it is 22 by 7 and it is 180 degrees. Actually pi radians is equal to 22 by 7 is a radian measurement, whereas 180 is the sexagesimal system. Therefore pi radians is equal to 180 degrees. Express the sexagesimal measure in circular measure. express the sexagesimal measure in circular measure. 15 degrees, 30 degrees, 45 degrees, 60 degrees, 135 degrees, 150 degrees, and 270 degrees. Now, 180 degrees is equal to pi radians, we have seen according to the definition. Therefore, 1 degree is equal to pi by 180 radians. So 1 degree is equal to pi by 180. So to convert all these degrees into into radian measurement, we have to multiply them by pi by 180. 15 degrees is equal to 15 into pi by 180. And 15 goes 12 times here. Therefore, this is pi by 12 radians. Either 30 degrees is equal to 30 into pi by 180, and this is pi by 6. 45 degrees, 45 into pi by 180, 15 goes 3 times and 12 times, 3 goes 4, therefore this is pi by 4. So therefore 15 degrees is 15 into pi by 180, pi by 12 radians. 30 degrees is 13 into pi by 180, pi by 6. And 45 degrees is 45 into pi by 180 is equal to pi by 4. 60 degrees is equal to 60 into pi by 180. This is pi by 3. 135 degrees is 135 into pi by 180. This is 3 pi by 4. 150 degrees is 150 into pi by 180. This is 5 pi by 6. 270 degrees is 270 into pi by 180 is 3 pi by 2. So all these are radians. Every time we don't write pi by 3 as radian, because whenever we observe pi by 3, we accept it to be radian. So therefore 60 degrees is pi by 3 radians, 135 degrees is 3 pi by 4 radians, and 150 degrees is 5 pi by 6 radians. 270 degrees is equal to 3 pi by 2 radians. This is the way in which we change the sexagesimal system into the radian measurement. Now express the circular measure in sexagesimal system. Express the circular measure in sexagesimal system. So we will be given the angle in the circular measure, we have to convert it into the sexagesimal system. Pi by 12, 5 pi by 2, 3 pi by 4, 5 pi by 6. Now pi by 12 is radian, pi is 180 degrees by 12, therefore this is 15 degrees. And 5 into pi by 2 is 5 into 180 degrees by 2. So therefore it is 450 degrees. Now 3 pi by 4, this is 3 into 180 by 4 degrees. Therefore this is 135 degrees. So pi by 12 is 180 by 12, 15 degrees. 5 pi by 2 is 5 into 180 by 2 equal to 450 degrees. 3 pi by 4, 3 into 180 by 4 equal to 135 degrees. Now 5 pi by 6 is 5 into 180 by 6 degrees. Therefore this is 150 degrees. So this is the way in which we convert the radian measurement into sexagesimal system.